Hello everybody, Mr. Rubo here. Today we're going to continue with topic 1.11, and yeah, we're going to look at slant asymptotes today. So given a rational function, if the degree of the numerator is 1 greater than the denominator, then the rational function has a slant asymptote. Okay, so degree 3 over degree 2, degree 4 over degree 3, right? It's got to be 1 bigger, and that is how we get a slant asymptote. So you can kind of see here's an example. Here's the function that this graph is of, and it's a degree 3 over degree 2. We have it then in factored form. We even have a hole at 2 and a vertical asymptote at -1. And x-intercept at 0 as well. I know that doesn't say it, but hey, still good to analyze this graph. And it has this slant asymptote at y equals x plus 1. Because it's linear, we write it in y equals mx plus b form. Slope is rise 1 over run 1, so 1. And then our y-intercept is positive 1. So that's where the x plus 1 comes from. All right, normally, though, to find this equation, you can't necessarily see it just from the graph. What we actually want to do, though, is you want to do some long division. Okay, so that's what we're going to look at today, is just kind of a refresher on how long division works. So we're going to look at the long division, and yeah, let's do this. So first thing, let's start with numeric long division, just because it's very similar. So remember, the first number goes inside the house, the second number goes outside the house, right? And then we're just thinking, okay, 21 doesn't go into 6, but 21 goes into 67 3 times, right? And then we multiply. So 1 times 3 is 3, 3 times 2 is 6, 63, and then we subtract. So that's the algorithm, right? Figure out how many times it goes in, put that number on top, multiply, subtract. Then bring down what we got left. Then do the process all over again. So 32, because 2 times 21 is 42. And we have a nice remainder here. So our quotient is 32, which is that top number. Our remainder is 4. So if we were to write our answer, we would write it as 32 plus 4 over what we divided by our dividend, which is 21, which normally we would just write as 32 and 4 21s, right? When it comes to polynomials, it's a little different, but it is basically the same algorithm. So we're going to put the first polynomial in the house, second polynomial outside the house. If you are missing any of the terms, so here we have x squared, x, and then a constant, and then we have a linear term and then a constant term. If, let's say, we were missing the linear term in this one, I would put 0x, like put a placeholder there, because it'll make the math a little easier. So now the way it works is all we look at is the first terms. And we think, okay, what do we need to multiply 2x by to get 6x squared? Well, that would be 3x, because 3x times 2x is 6x squared, but we have to multiply it by everything. So we also multiply it by the 1. So we say plus 3x. Okay, so that's that multiplied, and then there's that multiplied. We get this answer, and just like with numeric, we subtract as our next step. This cancels. 7x minus 3x is 4x, and we bring down the last term, and then we continue on. And again, guess what? We do the same thing. We look at first term, say, what do I need to multiply 2x by to get 4x? Well, that would be just 2. And then you multiply everything by it. 2 times 2x, 2 times 1, and then we subtract. Okay, make sure you subtract. Okay, so 4x minus 4x, 6 minus 2 is 4, and there's our remainder. So our quotient is 3x plus 2. Our remainder is 4. So if they just wanted the division, we would write our answer like this. Oh, not a 3, that's a 2. Just like we did for the numeric long division, polynomial long division is the exact same, except we can't simplify any of this because none of these things have like terms. So, cool. All right, there we go. Have a fantastic day.